Okay, so this is our final catastrophic event, and this is probably the one that affects us the most here within the Red River Valley, being that this is actually an aerial shot from the 2009 flooding. As you can see, the winding sort of pathway that is the Red River here in the Fargo-Moorhead area. So we are still working with Middle School Earth Science Standard 2-2 and 3-2. 2-2 states that you'll be able to construct an explanation based on evidence for how geoscience processes have changed Earth's surface at varying times and spatial scales. And then 3-2 states that you'll be able to explain what causes catastrophic events to form and occur using data to predict and mitigate future events. So that is the process that we are currently in within Fargo-Moorhead. We keep getting dumped on with snow, storm after storm after storm. So now what is the likelihood of flooding based off of the amount of moisture we have? So you are going to be able to interpret weather data to predict potential meteorological causes and catastrophic events. So make sure you have your whole group notes out in front of you, and let's talk about flooding. So flooding, very, very basically, is an overflow of water onto normally dried land. Okay, so where water doesn't usually sit and pool for like longer than an afternoon, like after a rain shower or whatever, this is considered flooding. Now, typically it's caused by rising waters in existing waterways. So rivers, streams, drainage ditches, all of which I live near. Not a fan. My lot floods every year. So there's things like that you have to be cautious, cautious of. And this usually lasts a couple of days to a couple of weeks, depending on where you're at, the severity, the infrastructure to be able to take care of the flooding and things like that. Our flooding in some areas, it's just a couple days because then we are able to get pumps and things like that in there and out, push all of that excess water out. But in other areas, like down in Lindenwood Park, it lasts weeks because there's just so much of it that we can't do anything. It just needs to kind of go down on its own. So that's flooding, like nutshell. There are 5 different causes that bring on flooding. So only a couple of these truly affect us, typically 2-ish. But these are the other ways that other areas can flood, and especially those that experience flooding yearly as well. So we have high coastal king tides, so these are really fancy tides. Coastal storm surges, so like when hurricanes or cyclones are moving inland, dam releases, heavy rainfall, and snowmelt. So again, another picture. This, I don't know where this is, but it's in North Dakota somewhere. So tides. Never thought you were going to come back to tides, did you? So let's review what a tide truly is and what causes it. So tides occur twice a day on our Earth, and this is due to where our moon, our Earth, and our sun are within certain elliptical patterns within their orbits. So during a new moon, we tend to see very, very strong tides, and also during a full moon, and that's because you get all 3, the sun, the moon, and the Earth, or Earth and the moon, in a straight line, and you have all that gravitational pull. King tides can happen about once to twice a year. It doesn't mean that they always happen, but they can, and that is higher than high tides. So this is typically when you would also get like eclipse, just because of the way that everything is lined up. Okay, so king tides are when you get like solar eclipse or lunar eclipse along with like being at the right tide moment. You get morning tides, you get evening tides, high tide, low tide, that sort of a thing. All of this then can affect these areas. Now, the great thing is that in certain like countries, or in our case, certain states, we prepare for that. Okay, so we build our structures higher than where even king tides would go. And things like that, just as a way to prevent or mitigate possible damages. Now, not everybody is able to do things such as that. They're not able to ensure that people aren't even just having to sleep out toward the coastlines and all that kind of stuff. So it's not as great. Storm surges. So again, this is kind of like when a hurricane or a cyclone are moving inland from the middle of the ocean. Now, storm surges truly matter depending on where the tide is at that time. So if you are having a storm surge near high tide, where tide is already higher than typical, so we have our barriers just in case that it's a little bit higher than typical. And all this, but it doesn't necessarily prevent anything, because then you're adding just that much more volume of water within a very small area, to where you can see during high tide on this top picture where like regular tide would be, high tide would maybe go to the top of this thing, but if you have a storm surge in the midst of that, it's going to go up, and now this structure is completely flooded out. Okay. And then you have when it happens during low tide. So again, typically tide is right here at like surface level. Low tide is where a lot of it goes out to where it drops. But then once you get a storm surge, it comes up and it hits probably where high tide typically does. We don't have nearly as much of an issue. So this is something that people really have to take into consideration. Now, this is a poor picture because anyone who lives on any coastlines knows not to put your house at sea level. Usually they're built up on stilts ever so slightly, just to allow for that excess water to go under it without causing any actual property damage. Things you learn on different coasts. Okay, so that's it for whole grip. I just wanted to make sure that I covered what tides were again, because we haven't talked about them since Q1, and then what storm surges truly were. Just because now as you get into the rest of it, it's pretty well-known fact, because they're things that we take into consideration within our area. So please be sure that you are minding your chance expectations, and if you're continuing on with me, awesome, let's keep going. So a dam release. Now, obviously, we need to define what a dam is. Most people do. But this is a structure built across a stream or river to hold water back. Typically, it's to either store water, to control flooding, or to generate electricity. So as the water passes through, it can move generators and produce renewable energy. Control flooding, if you know that flooding occurs, well, if you hold it back in more of a reservoir or a lake before you let it out toward the river, or let it out in very small amounts, you can then protect those around in the surrounding areas from that. And then storing water, if you go through droughts quite often, whatever water you can store to be able to keep going down stream for irrigation and things like that. That's kind of what happens. Now, like using a dam is really, really good if it doesn't fail. So dam-related flooding is typically due to the fact that the dam itself has failed in one way. Typically, it is excessive water then flooding through down to lower land. And because of dams, humans get really, really gutsy and moves closer to where the shoreline typically would be, or down into that lower land area, to where then if the dam does fail, their houses are gone. Typically also with dam failures, it's not predictable, to where people cannot prepare and get out of the way. So if it happens, typically this is where we see a lot of that loss of life, just because no one knew it was coming. So dams are great. They can be awesome resources, but if they fail, they fail hard. Heavy rains. So this is if you are heading on I-9 or I-29 north out of Fargo-Moorhead. Again, the 2009 flooding. So heavy rains. Now, what does this truly mean? Well, for areas like ours, it depends on what kind of a spring you're having. So if you have a very, very wet spring, but it's been very, very cold up until that point, our soil, because it's clay, is already saturated with so much water that it can't take any more in. Or it's still frozen, so it's not taking anything in, it's just trying to thaw. To where we have issues like this. I just remember, I don't remember what year it was. It was either 2011 or 2012. Driving back up to college after a weekend at home, and I couldn't see the road, which not safe. But I-29 wasn't closed at that point in time, and I had to get back to school. So yeah, it's crazy. So if no matter what area you're in, but if you have a wetter than normal spring in soil that's either still frozen or it doesn't absorb nearly as much, it's asking for flooding to occur. But obviously, as you can kind of tell from these pictures, humans try to make do with what we know. So you can see here that the road is much, much further elevated than down in the ditches, to where the road you can still see. You can even see this farm road back here. But we do this so that we can still get back and forth from where we need to. I mean, this is how you get from here to Grand Forks. Things like that. So we make do in that way, knowing that our soil more than likely is still frozen under here, or it's at its absorbency level. It's not going to take anything more in. And then snow melt. This is where I'm a little worried this year. So if we get an abundance of snowfall during the winter, and if it never has chances to slowly thaw and melt, kind of in increments, you're starting to set up a recipe for disaster. Then, if it goes into a very quick spring, so you get a stupid amount of snowfall, and then you get a very, very nice spring for a very, very long period of time versus our like fall spring, that the ground doesn't have time to thaw, so all of this water just needs to go somewhere. And typically it's into a low-lying area. Heavy spring rains then don't help any. And then we have to start taking other things into consideration, like ice jams. This is where you get these big old pieces of ice on the rivers that get broken apart, but then once they come and meet something like a bridge or a culvert or something like that, they get in the way and they stop the flow of water from as easily going through as possible, to where then you might be good down towards the southern side, but up towards the northern side, not so much. You now are starting to get flooding back there, and it's all because of these ice jams that are just getting in the way and reducing the flow of water through these areas. So far at this point in time, I was just looking at some things. Granted, it hasn't been updated since late January, and we've had quite a few major snowstorms since, but we are still sitting at a relatively low risk of flooding this spring, only because right now our river is sitting at about 15.07 feet, and we don't start taking any sort of flood action until I think 18 feet, if I was reading correctly. Yeah, so then we start preparing. That's where we start asking for sandbags to be made and all that other kind of fun jazz. So just so you're aware. Sorry. Now, flooding typically comes in one of two ways, whether it's a rapid onset or a slow onset. I hope you can kind of tell the difference. So rapid onset would be it develops quickly and can last for 1 or 2 days. This could happen with little to no warning. Infrastructure just can't support it. So this is kind of like with the failure of a dam, things like that. Slow onset develops more slowly and can last for multiple days or weeks. That's what we would be looking more toward. Heavy rainfall over too many days, infrastructure just can't keep up. So typically areas that are more prone to slow onset floods have the infrastructure in place in order to deter the water. That's why we have the divergence and things like that within the Cheyenne and the Red River. Um, so things like that, different dams and things like that can also then be infrastructure that helps slow down flooding or hopefully cause far less damage. So those are the two ways that flooding can really take on. With the rapid onset, that would happen in places like India, where it's very, very dry, and honestly, the soil doesn't even know what to do when it gets so wet, and it starts raining for multiple days to where you have streets completely flooded out. So those are another um, example of like what rapid onset can be, not just dam failure. So let's talk about the Red River in particular because you guys don't care what happens in India necessarily. You don't necessarily care about how, like, when the Mississippi floods, like what that does, and all this, like super down south. We care about what's happening in our backyard. So these are just different examples of what has happened in the past. So typically, the Red River is relatively slow. We have fast or flat slopes allowing water to backfill into tributaries, things like that, small streams that flow into larger rivers, all this kind of stuff. But our biggest thing when it comes to predicting floods is how the ice is coming out of the river. So how we get ice out on our river and into our lakes and all that kind of fun jazz, because typically it's ice jams that get in our way, which then allows for more flooding to occur. I live out in Horace. You have to go over the Cheyenne to get out toward my house. And as we drove past these last like week, there's been a bunch of these little like, I don't know, are they called snowcats? Things like that. They're not snowmobiles. They're like the four-wheelers on the treads or whatever. But they've been hauling around these big metal, like half spherical things and filling them with a bunch of like debris and large sticks and branches that have fallen off the trees over the winter and things like that. And putting them in these things and then burning them to get rid of this. This is a form of prevention or mitigation. By going through and picking up these larger sticks and stuff that is just going to jam up our culverts and our bridges and things like that, the more we can hopefully prevent flooding within areas. So, this I found just kind of interesting. So Fargo has a 95% chance of reaching 19.1 feet, 75% chance of reaching 21.5 feet, 50% likelihood of 24.5 feet, 10% of 34 feet, 5% chance of 36. And all of this was back in 2009. So yes, some of you were just babies. Some of you, I don't even know if you were a twinkle in your grown-up's eyes. I was in high school. It was my senior year of high school. So all of this, like it's scary to think of that our river can get so deep and cause such significant damage. So flash floods. This tends to happen more in your dry, arid sort of climates. So very, very quick. Short periods of heavy rain or excessive rain, generally less than 6 hours worth of rain. again, this is like soil that doesn't know what to do with all the water. Naturally causes riverbeds, urban streets to flood, mountain canyons to flood. This is where you also then get mudslides, landslides, all this kind of fun jazz. Unnatural causes could be from levee failure, dam failure, debris, ice jams, things like that. Flash floods are never good. Again, the quicker things can come on, the less prepared that people can become for events like this. So let's talk about how humans are playing a factor into this. So humans are starting to cause more and more flooding. In the case up in this top picture, this is a picture of what a forest with a river running through it generally looks like. But as humans come in and we take out all of the trees where the roots suck up all of this extra moisture and can then be transpired excuse me, transpired into the atmosphere and things like that to keep water level healthy, it starts to flood because there's nothing sucking it up. It only has the soil. Then you have landslides and all this kind of fun jazz. And this is all typically brought on because of new land development and infrastructure failure, impenetrable surfaces, so anything concrete, tar, all that kind of fun jazz. Bridge constrictions, if you put a bridge up, you are essentially slowing down more of that water. So then if it's not able to move the excess water out quick enough, it has nowhere else to go. Flood embankments. So if we're taking away embankments to begin with, but then we go and we're pushing our own waste into the rivers, well, that's not great. Already kind of explained deforestation and then climate change. As we heat up the atmosphere, it does hold more moisture, which means then that it can release more moisture over colder areas. Allowing for more flash floods and things like that to occur. So it's not good for so many reasons, and there are so many ways that we can prevent it by just stopping some of this stuff. Now, can we completely stop land development? No, but could we plant more natural foliage and trees and things like that within those areas to again take in that extra moisture that's now being displaced because of your driveway? Yes. All that kind of stuff. So predictions. Flooding of all of the catastrophic events that we have talked about thus far is probably one of the ones that we actually can do a little bit more prediction with. And that's because we can look at data. So past floods, we can look, especially again, here within Fargo-Moorhead, if we look at how the Red River has flooded in the past, we know where the water wants to go because those are the low-lying areas. Those are typically the ones that get the first set of sandbags that go out. We can look at the behavior of the water bodies, so like the rivers, the lakes, the ocean waters, things like that. How does the water naturally flow or behave to where we can then build around these twists and turns? Like if you look at the Red River, it is twisting and turning and you get all these oxbows and things like that. As long as you don't try to make it straight, you should kind of be able to mitigate some of those things. Looking at amount of rainfall while it's raining, typically the amount of rainfall that an area gets is pretty stable-ish. So things like that. Looking at water level. This is another reason why we can predict that our flooding this spring shouldn't be terrible because our water levels were so low going into freeze that, well, now we're just making up for what we already lost. Types of storms and precipitations we tend to get, the size of the storm, the soil, ground temperature, size of forest, risk of erosion in that area, all those sorts of things. The more we take the trees away from the banks of the Red River, the more likely it is to flood. Okay, so just kind of looking at things like that. Changes to the area, so deforestation, that is like taking up too many trees. Farming, essentially for farming, you're taking out natural resources that take in that water. You're prescribing a certain amount of water that they get by watering it so many days, things like that. It's not great. That, and then finally erosion of any sort of land. So moving of soil away from where it truly belongs. Mitigation. So this one's a little more challenging because it's very technical. So mainly it comes with a bunch of alerts. So if we look at sensors, so getting information out to those without internet. In our area, not as big of a deal, but like in places like India and underdeveloped countries that are affected by the Nile River and things like that in Africa, getting information to local agencies that then can get it out to the public. So that sort of thing. Artificial intelligence. So looking at patterns in the past flood to predict what will happen with future floods. Again, this is running data and algorithms and things like that to be able to see, okay, like for this picture, I wouldn't build anywhere in that red. To me, red, not good. Things like that. And then finally, SAR, SAR, and this stands for Synthetic Aperture Radar. And this is a form of radar that is used to create two-dimensional reconstructions of objects such as landscaping. So basically it's like looking at topography and seeing, okay, this place is really high, this place is really low. Well, which one is going to be more susceptible to flooding? Well, the really low one. So yeah, it's a lot of numbers and observation and just communication. And communication tends to be the biggest issue. We are not, like, people should not be surprised if the Red River starts to come into their backyard, because we would have been able to predict that, like, when you purchase your home, it has to be assessed by the county to identify whether you are or are not within a flood zone. I just barely make it out of a flood zone, but it would then also cause for extra taxation, because then if we are within flood warnings, then we have services coming into our properties and sandbagging to hopefully keep the main structure of your home safe. Things like that. So you shouldn't be surprised because we can get the information out there, but it's other underdeveloped places that don't have the infrastructure to be able to support it. That's where we see a majority of the issues come in. Now, once flooding happens, again, it's a catastrophic event, so it's not something we can stop. Once it's going, it's going. But how can we respond? Well, sandbagging. Sandbagging is a big thing. This is a picture of some of our former 8th graders that went to Sandbag Central a couple of years back and helped fill sandbags. Closing and sealing all gaps. So we have basements in the Midwest because we can technically support that. We don't typically sit below sea level. So making sure that you're sealing off any surfaces close enough to the outside land level where flooding would then start coming in, sort of a thing. Turning off gas and electricity. So obviously electricity and water, they don't mix. It just, that sort of thing. Gas, similar, where you don't need a fire being spread on gas or oil on top of the water and then going around, that kind of fun jazz. Move necessary items. So this is if you know that you are going to flood. If you have a safe in your basement, get it up to the top floor. Valuable pictures and things like that that you would not want to get contaminated or contaminants to get into the water, things like that. Move all of them as high as you possibly can within your home. This is something that I struggle with. It's like, okay, where do we put the safe? Do we put the safe on, like, up in the bedrooms, which are upstairs, and then risk fire, where then that's just going to go all that? Or do we put it here like on the middle level or the main level of the home to where it can get out with us quickly, but it's not necessarily going to get flood damage, things like that. Um, when I say contaminants, I mean like everything underneath your kitchen sink. Get it out from under there where hopefully then it will not pollute the water because then we just have other issues. Evacuate. If they tell you to get out, get out. Don't stick around. Don't be the guy who watches the tornado and tries to like record it. Don't do that. Just get out. And then after a flood, make sure that you're taking every safety precaution possible because you don't know what you may be walking on, walking into, the amount of chemicals that were there, molds left behind now because it's had time to dry, all that disgustingness. So just make sure that after a flood, you are keeping yourself out of danger. Finally, stay away from the water. Flooding is no joke. It only takes 6 inches of somewhat fast-moving water to knock down an adult. It takes 2 feet to carry most vehicles away. So that's why I'm like, oh, I probably shouldn't have been driving on I-29 over that time. Granted, it was not 2 feet, and it was not fast-moving water in the least bit. But it's not good for your vehicles either. And you don't want to go over somewhere that has flooding occurring because you don't know if there's actually a road there or not. So this top, like the larger picture, yes, very dramatic. But if the waters were higher and you just see across the way, you're like, oh yeah, no, I can do this. Like the road's right there. I just got to get home. And really, it's this deep? No, no. And like I said, it only takes 2 feet to carry most vehicles away. So if you imagine going into a kiddie pool, that's all it takes. So please be cautious. So that's flooding. Hopefully it was a little bit more meaningful, being that it was stuff that occurs to us here in Fargo-Moorhead. If not, pretend like it does. Okay, there are for sure 2, maybe 3 exit tickets that need to be completed all over floods, and then your exit ticket packet should be complete. Make sure you get your notes done and turned in, and that's all I got for you. If you have any questions, reach out, let me know. I want to help. Yeah, let's hope that we're not flooded out this spring. Yeah, awesome, great. Thanks, 8th graders.